we are going to talk about multiplying and dividing radicals. It's as simple as this. You can multiply the numbers that are not underneath the radical, and you can multiply the numbers that are underneath the radical and leave them underneath the radical. 2 radical 3 times 5 radical 7. I can multiply 2 times 5. I will get 10. Radical 3 times radical 7 is radical 21. Now, if I can break down 21 and simplify it, I would. I cannot break it down into anything that's a perfect square, so I am done. This one I am not quite finished. Radical 50 has a perfect square in it. Radical 50. Remember, a lot of times these numbers, I'll divide it by 2, divide it by 3. I'm like, oh my goodness, 2 times 25 is 50, and 25 is perfect. Get it out of jail. Set it free. Yes, I know that is corny. Radical 25 is perfect, so we are going to get it out of jail. And when it comes out of jail, it's a new and reformed number. Radical 25 is perfect of 5. We can multiply the numbers that are outside the radical. Negative 3 times 5 is a negative 15. And inside the radical, we have radical 2. Can I multiply negative 15 times 2? No, you can't. One is underneath the radical and one is not. I am done. Dividing works the same way. 8 and 2 are both not underneath the radical. I'm going to reduce those just like I did in 3rd grade. 2 will divide into both of those evenly. 2 will go into 2 one time. 2 will go into 8 4 times. That would be 4 over 1, or just 4. I don't really need to put the over 1. And we have radical 10 over radical 5. Yes, those will reduce too. 5 will go into both of those. 5 will go into 5. 5 will go into 10 2 times. In the numerator, I have radical 2. In the denominator, I have radical 1. Well, radical 1 is just 1. And 1 times 1 in the denominator is just 1. My answer is 4 radical 2. Some people like to write one big radical. I would have radical 10 over radical 5. That would be the same thing as radical 10 over 5, which is still radical 2. Well, 2/7, 2 over 7, that's outside the radical. I cannot reduce those. That will just remain 2 over 7. Remember, I could write this over one big radical if that makes you feel better, but 27 divided by 3, that would be radical 9, and that is in the numerator, or if you're wanting to cancel this, you could. Am I done? No, you're not done. Radical 9 is perfect. It gets out of jail, yes, and when it comes out of jail, you know what it is. It is new and reformed. 2 times 3, I can multiply those because they are both not underneath the radical, and it will be 6 over 7. Oh, look at this. I have a monomial times a binomial. That radical 6 is multiplied not by 7, not by radical 2, but by 7 plus radical 2. It's a binomial. Well, you have to make sure that you use the distributive property. Radical 6 times 7 is just 7 radical 6. I cannot multiply 7 times 6 because 1 is underneath the radical, 1 is not underneath the radical. Plus, radical 6 times radical 2 is radical 12. 2 times 6 is 12. Am I done? No, you're not done. I am done with the 7 radical 6. 6 has nothing perfect in it. But 12, I could break that down into 4 times 3. Radical 4, we know, is perfect perfect of what? 2. So when it comes out from underneath that radical, it is 2. My answer will be 7 radical 6 plus 2 radical 3. Now I am adding these. Now we haven't gotten into adding radicals yet, or maybe you have. Maybe you've watched that video first. But I can only add and subtract radicals if they are like radicals. This is a radical 6. This is a radical 3. They are not alike. You are done.